Okay, welcome back to Pure 4, Chapter 3, Coordinate Geometry in the XY Plane, another fantastic resource from Dr. Frost. So, chapter overview, what we're going to look at is something called parametric equations, and we're going to look at how we convert a parametric equation to Cartesian form. Now, Cartesian form is what we're used to, y equals something x, okay, that's what we're used to. Parametric is, for example, x equals 2 cos t plus 1, and y equals 3 sin t, and then we want to actually put it into something that we understand. And then what you all love doing, we're going to be sketching curves, okay? It's going to be fantastic. So, what are they, and why do you even need to learn about these? So normally we have two variables, x and y, and we can have a single equation involving x and y, which is our Cartesian equation. This is what we know, we love, we're used to, okay? But for any of you who have been studying mechanics, you might want each of the x and y values to be a function of time, perhaps, okay? It's not just as, life doesn't revolve around y equals mx plus c, as much as we would love it to, okay? We do have circles, we do have waves, we do have graphs that, when you go into physics, chemistry, biology, you're looking at rates of change over time, for example. There's so much. So this allows us to express different particles, even light waves, everything. And when you think about this as well, this is the basis of a lot of computer software, okay? All these graphs. Think about animations, think about all the games that you play. Behind all of this, there is a lot going on. So they're known as parametric equations because each of the x and y are defined in terms of another variable. Normally, the parameter that we use is t, okay? And it is normally expressed as a vector, but we can come more into that later. So, what we're going to look at is we are going to look at how we convert parametric equations to Cartesian form, okay? How would we do this? Now, it is nice and simple, okay? Good old-fashioned substitution. Okay, so here we have x equals 2t and y equals t squared. Well, we're literally just going back to GCSE kind of level maths here, where we are substituting. That's all we're doing. So we know we want to rearrange one. So we've got x equals 2t. So that means t equals x over 2. I know that y equals t squared. So I can substitute in y equals x over 2 squared. So I know that y equals x squared over 4. So here we go. I have now converted my parametric equation into Cartesian form. It's as simple as that. Now, the domain of the function, what we do is we look at, here it says that minus 3 is less than t is less than 3. Now we know the domain affects the x, okay? Domain, we should always be thinking x. So if we have minus 3, t is less than 3. Oh, sorry everyone. Minus 3 is less than t is less than 3. We know that x equals 2t. So if I multiply this by 2, what do? I'm going to have minus 6 and 6. So therefore, our new domain is minus 6 is less than x is less than 6, because we know that x equals 2t. That's what we know. It then says, and the range, find the range, okay? So the range of f is the range of q, essentially. But this one's slightly harder, okay? Because we have to do what it says. So we know when we think about the range, we think about y. So what did we originally have? Minus 3 is less than t is less than 3. Okay? So, here, what does y equal? y equals t squared. So I need to figure out what t squared is. So what I'm going to have is 3 squared and minus 3 squared. That's what I'm going to have. I'm then going to find that this is going to give me 9 is less than t squared is less than 9. We know t squared is actually what y equals, don't we? Well, this doesn't make sense. Okay, but what we do then know is we know then that y has to be less than 9. Okay? What else do we know about this equation? We know this equation is x squared over 4. If you think about the x squared graph, it doesn't matter if it's been divided by 4. What type of graph is this? Okay? It's a nice smiley face. So what is going to be our range of values for our y? Anybody know? What do you do when in doubt? Draw it out. Draw it out and show me what that looks like. So it is clear to see that the graph of x squared is always positive. So that means that it's also, our minimum point is always going to be greater than or equal to 0. We know that. We know the x squared graph looks like this. And what we're essentially saying is in between the values of -6 and 6. So that means my range is going to be from here down to here, wherever 6 is going to cut across. This is what we're saying. So it's going to be 9 and 0. The reason why it's greater than or equal to 0 is because we know our minimum point, our minimum of any quadratic x squared, if we don't have any plus x's or plus c's, it's always going to be 0. Okay? So really think about this. This is where the saying really comes to life. When in doubt, draw it out. Because what you would do is substitute these values in, but you need to, it's not just about knowing a method, it's about actually knowing what's going on. Okay? So really think about what's going on. So the answer here is 0 is less than or equal to y is less than 9. Okay, so that will give you the full marks. Okay, here we go. Another example for you, because this one's slightly different. So a curve has the parametric equations x equals ln over t plus 3 and y equals t plus 5. Find a Cartesian equation of the curve in the form y equals. So again, what do you think we're going to have to do? If I want y equals and I've got a t, and I've got an x equals and I've got a t, I need to actually, whatever my x equals is, rearrange that to get my t. Okay? So, part A, we're going to start with, I don't want blue. Let's go back to black. A. So we know that x equals ln of t plus 3. How do I get rid of a ln? We know a ln is a log to the base e. So, e to the power of, so I know I'm going to have e to the power of x equals e to the power of ln t plus 3. Okay, now I normally wouldn't write that, but it's just to, so we do double check that we know that this cancels to give us t plus 3. How am I now going to find t? I'm going to take away 3. So e to the x minus 3. This is what equals t. I now have what t equals. I'm going to substitute this into what y equals. So I know that y equals 1 over t plus 5. That means if I substitute this in, I'm going to get y equals 1 over e to the x minus 3 plus 5. So y equals 1 over e to the x plus 2. We've done it. This is great. Okay, this is amazing. So, now it says write down the range of f of x. Okay? So, what we will start is what we know. Sorry everyone, we still need to find k. Finish the first question. So for part A, so we need to find the domain here. So when we need to find the domain, what I'm going to try is, in the question it says when t is greater than -2. Now when I'm looking at the domain, what I'm actually looking for is my x equals. So I'm going to use this and I'm going to use this. So I'm going to see what happens. So I know when x equals ln of t plus 3. Let's see what happens when we actually substitute in t equals -2. Now I know that t needs to be greater than -2, but let's see what happens. I'm going to get x equals ln of -2 plus 3, which is 1. We know that ln of 1 is in fact 0. So that means that in our domain, x will have to be greater than 0, okay? Because as t increases, okay, so does ln t plus 3 increase. They're all going to increase at the same time because t has to be greater than -2. If we put in -1, we're going to get a number greater than, okay? And then we're going to see that happen. So we know that x has to be greater than 0, so therefore k equals 0, because it says here, what does x have to be greater? X is greater than k. Okay, so we found our domain. Now it wants us to find our range. So our range of values, again, when we think about the range, we think about our y. So what we're actually going to do is, we know that y equals 1 over t plus 5, and we know we're going to let t equal -2, okay? So we're going to have y equals 1 over -2 plus 5, which is a third. Okay, so we're going to get y equals a third. Now, let's think about this. T has to be greater than -2. If I put in then t equals -1, I'm going to get y equals a quarter. Okay, if I'm going to get t equals 0, I'm going to get y equals 1 over 5. If I'm going to put t equals 1, I'm going to get y equals 1 over 6. So what's happening each time is the values are decreasing. So as y equals 1 over t plus 5 increases, okay, as the value of t increases, this value decreases. That means then our range of values is y is less than a third. Now, you will understand when we look at fractions what happens when a value increases, what happens to the function, does it decrease or not. But for now, this is why I'm just substituting some values in so you can get a picture of what's going on if we kept going. Okay? Okay, here we go. Test your understanding. You've got 2 past paper questions here, okay? You can see not very many marks. 4 marks for this question and only 3 marks for this question. It just wants you to find the Cartesian form. I'm going to give you extra points if you find the domain and range for me. Off you go. Okay, so what are we going to do when we have trig identities? Bum, bum, bum. So, everyone is happy that sine squared plus cos squared equals 1. Everyone's happy that 1 plus tan squared equals sec squared. Okay, these are the types of equations that we are going to use. So, example 1. A curve has the parametric sequences x equals sine t plus 2 and y equals cos t minus 3. Okay, step 1. Rearrange to get sine t. Okay? So for the first one, x minus 2 equals sine of t, and y plus 3 equals cos of t. What trig identity do we know that links sine and cos? We know that sine squared x plus cos squared x equals 1. Now you can see here we have x. Okay, it's completely fine if we had t. X is just a number. In our case, our number is now t, isn't it? X is an unknown number. So, instead of, we know that sine squared x is actually sine of x all squared. It's just how we write it. It's just a notation, isn't it? Plus cos of x squared. This equals 1. I know what sine t is. Okay? Sine t is x minus 2. So what am I going to substitute in where it says sine x? Actually, to make this less confusing, let's turn these to t's. But everyone should be happy that this is just a formula and we adapt it to us, don't we? Okay, so this means I'm going to have x minus 2 squared plus y plus 3 squared. This equals 1. I've substituted this in. There we go. We found a Cartesian equation, because Cartesian means using our x and y's, isn't it? It's a form we know and we love. Hence, sketch the curve. I wonder, you're looking at this, what do you think? Circle, pure 2 circles. Okay, centre of the circle is going to be 2 minus 3. Okay, I've literally just uploaded a video on YouTube about circles, so if you need to scrub up a little bit, go ahead and watch it. And our radius is the square root of 1, which we know is 1. So our radius squared is 1. So if I was to draw this as a sketch, step 1, draw your axes using a ruler and a pencil. X, Y. Step 2, roughly think about where 2 minus 3 would be. And I'm going to put it here. Okay, you then need to draw a circle. Now, if you're not very good at drawing a circle, get a compass out. Okay, or watch me do a magical circle. Look at that. Best circle I've ever drawn. Okay, you need to label the centre, 2 minus 3, and then show that the radius equals 1. Okay? Now, if the radius was bigger than 1, if the radius was 3, we know that the outside of the circle would come into the positive section here. Okay, really think about what's going on. I know it's a sketch, but you still have to be like a realistic sketch. Okay, nice and easy question. Okay, moving on. Are we ready? Second question. A curve is defined by the parametric equations x equals sine t, y equals sine 2t, and we have these values between minus pi over 2 is less than or equal to t is less than or equal to pi over 2. So find a Cartesian equation of the curve in the form y equals. Okay, so we need to find y equals. Right, first of all, I know x equals sine t. There's nothing more I can do about that. That is just, can't rearrange it. That is it. Y equals sine of 2t. Hold on. What does that sound like to you? You're right. Double angle. Exactly. You know it, you love it. So, instead of sine of 2t, we know that using the double angle formula, this is the same as writing 2 sine t cos t. Okay? Which is great. But now I've got a sine t and a cos t. I don't really know what to do here. What do I know about cos t? Okay, if we're going to have it all in sines. Okay. We know that sine squared x plus cos squared x equals 1, right? So we know the square root of 1 minus sine of x, this equals cos of x, doesn't it? Yeah, we know that if I rearrange it. That's what we're going to rearrange. So we're actually going to get y equals 2 sine t root 1 minus sine x. Why have I done it this way? Because we know that x equals sine t. So if I get everything in terms of sine t, I can then substitute in x, right? And remember, sorry everyone, this is sine squared, isn't it? Okay, so now I can substitute in my x equals sine t. So therefore I get y equals 2x square root of 1 minus x squared. And I just realised I didn't write sine t here. I'll write sine. Okay? So whenever I have x equals sine t, so I want to rearrange the y so everything is in a sine t form. I don't want sine 2t. I'm happy with sine t or sine squared of t because I could just substitute in my x. So here we go. This is my new equation. How do you feel about sketching that? Yeah, we don't have to, so it's okay. Right then. Then what does it say we have to do? It says we have to find the new domain, okay? So, we know that minus pi over 2 is less than or equal to t, which is less than pi over 2. Okay, we want this. We want it to be for x. What did we do to t to then make it equal to x? We applied sine to it, didn't we? Okay? So for this to be equal x, that means I'm going to have to do sine of pi over 2 and sine of minus pi over 2. Yeah? So then, what is sine of minus pi over 2? Minus 1. Sine of pi over 2? 1. So this is our new domain. Therefore, k equals 1. Okay? Then it says write down the range of fx. Okay. So, let's think about this. So when we're thinking about the range, we're thinking about y. If we think about the graph of y equals sine of 2t, let's think of the graph sine of 2t. Okay, what do we know about the graph of sine? Goes up to 1 and minus 1, doesn't it? Our range is in fact between minus 1 and 1. Now let's double check, because do you remember last time our range was only between 0 and 1 because of our domain, and we need to see what our domain includes to see what it's going to put out. Now it's actually given us sine of 2t. Okay, so if you think about the graph of sine of 2t. Now sine of 2t, and it's actually between pi over 2 and minus pi over 2. That's what it says in the original, yeah? This is what it's between. Right, if I really think about this, sine of 2t, is it inside or outside the bracket? Inside. Who does it affect? X. What are we going to do with all our x coordinates? Divide them by 2. So that essentially means that if this is 90, we're now going to divide it by 2. So we're actually going to get, it's going to squish, isn't it? Okay? So, what we're actually going to have is our curve is going to look like this. That is the worst curve I've ever drawn. Wait there. Okay? Because instead of our maximum being at pi over 2, we're going to finish one here, and we know it's going to go the other way. So actually, in between this domain, the values of which I can substitute x in, I know that my highest point is my maximum, which is 1, my lowest point is my minimum. So therefore, the range is still going to be minus 1 is less than or equal to y is less than or equal to minus 1. Okay? When in doubt, draw it out. Really think about what's going on here. So a curve C has parametric equations x equals 2 sine t and y equals 1 minus cos of t. Okay, so what double angle formula do we know for cos of 2t? If x equals 2 sine t, okay, really I want sine t's, don't I? Yeah. So it's going to be 1 minus 2 sine squared t. So I know I can rewrite y equals 1 minus, and then using the double angle formula, 1 minus 2 sine squared t. Okay, so I've substituted that in. So I need to know what sine t is. Well, sine t is x over 2 equals sine of t, doesn't it? Okay, so what we're going to do now, I'm just going to substitute in. If I expand this out, what's 1 minus 1? Oh, look, y in fact just equals 2 sine t squared, doesn't it? Yeah? So when I substitute in my x over 2, I'm going to get y equals 2 lots of x over 2 all squared. Okay? X squared over 4 multiplied by 2 is in fact just x squared over 2. Okay? It then says state the value of the constant k. Okay. What did I do to... So look at this, right? How do I get x? Right, if this is t, how do I now get to x? What do I have to do? I have to sine it and then times it by 2, don't I? That's what we're going to do to these two values. Now, you know that sine of pi over 2 is 1. And then if you times it by 2, what do you get? 2. You know that sine of minus pi over 2 is negative 1. Multiply that by 2, minus 2. So our new domain is actually minus 2 is less than or equal to x is less than or equal to 2. Therefore, k equals 2. Does anyone need me to explain that a little bit again? Okay, so here we go. Just a bit of a side thing over here. Right. If I have t equals pi over 2, for example, okay? I want x equals, okay. So I know that t equals pi over 2, and the question for 5 chicken nuggets is, can you find out where x equals? So, what equation do we know? We know that x equals 2 sine of t, don't we? Yeah? So, okay, that's fine. We know what t equals. We know that x equals 2 sine of t. Okay, so let's think about what has happened to t. What did we happen? If we just had t on its own, okay, we can substitute in pi over 2 here. This will still give us the answer. But also look at it a different way. What happened to t? T's on its own, and then boom, 2 sine t. What did we do to t? We signed it, and then we times it by 2, didn't we? Okay, the other way you can look at it is you can just do the substitution. 2 sine of pi over 2, and this will give you 2. Okay, either way is fine, but it's really getting the brain thinking, oh, hold on a minute, what's happened? Okay, so a nice little side bit there. Right. So a curve C has a parametric equation, x equals cot t plus 2, y equals cos x squared t minus 2, and 0 is less than t is less than pi. Find the equation of the curve in the form y equals fx and state the domain of x for which the curve is defined. Okay, so we have cot and we have cos x squared. Okay, I know about cos x squared. What do I know about it? I know that 1 plus cot t squared equals cos x squared t. Now, because I know, we could rearrange this. Yeah? So I'm going to substitute in. So therefore, y equals, spelled that wrong, y equals 1 plus cot of t squared, yeah? Minus 2. Okay, what does x equal? X minus 2 equals cot t. Now I can substitute everything in. So therefore, y equals 1 plus x minus 2 squared minus 2. Okay? So now, I'm going to have y equals x squared minus 4x plus 4 minus 1. So y equals x squared minus 4x plus 3. Look at that, we've got a quadratic. That's great. Now, okay, let's think about this. So do you remember earlier we had different ways of thinking about it? So we could do the same thing again, okay? So we're going to have a look at this in two different ways to really focus on how we're going to find the domain. Right, again, we know 0 is less than t is less than pi. So to find what x is, we're going to do cot of 0 plus 2. And we're going to do cot of pi plus 2. Now, what you should find is when you put these into your calculator, you're going to get an error. Okay? Because what is cot? We know that cot is 1 over tan. Okay? We know the graph has asymptotes. It's going to tend to infinity. Okay? So, what we now know is when we substitute in, sometimes it doesn't always work, and this is a case where we get an error and it doesn't tell us that. This is why we really need to understand what's going on. If you was to sketch this, okay, what would happen? If you were to sketch cot, you know it's going to look like this. Oh, this is terrible sketching. We're going to have our asymptotes, okay? And with the plus 2, we're only going to move it up slightly. Okay, we're going to move the graph up. So what this actually shows us is that x can actually belong to any number, because it can go anywhere. Okay, so it varies. So then what we say is therefore x belongs to the real numbers. Okay? Then it wants hence sketch the curve. Now, if we were to sketch this curve, we're going to get x minus 3, x minus 1. So we know we're going to have roots at x equals 3 and x equals 1. We know that our y-intercept is 3. If I was to sketch this curve, it's going to look like this. We know this coordinate is 3, 0, 1, 0, 0, 3. Okay? So what we're going to be looking at today is sketching parametric curves. So we can see that one strategy is to convert it into a Cartesian equation, hope that it's something we can hopefully sketch like a quadratic or a circle, we saw that earlier on, and sketch appropriately. Sometimes though, it's not going to work like that. For example, okay, when x equals theta cos theta and y equals theta sine theta, the parametric equations in Cartesian form look like this. Don't know about you, but I have no idea how to sketch this, okay? Now, lucky for us, here we have it. Doesn't it look lovely? It looks like a little, like a snail or a seashell. Really nice, but again, have no idea. So, when in doubt, put values in and sketch it out, okay? New saying for this chapter. Right then, sketching parametric curves, take 2. Right then, so what we're going to do instead is to find out, as long as we rearrange it into x equals and y equals, it's literally a case of substitution. It says 0 to pi over 4. So to make it, what's the word? Not pi over 4. 4 pi. So what I've started to do is if I go up in quarters, essentially, okay? So 0, pi over 4, pi over 2. And what I would like you to do is to substitute in. So if I substitute in x, now this is what I always like to do this so I know what's going on. So x equals, okay? And I'm going to substitute in when theta is 0. So I'm going to have bracket, bracket, cos, bracket, bracket. And this is where I am substituting in these values. Okay, it's that simple. If I substitute in 0 into here, I know straight away 0 times cos of whatever it is in fact 0, is going to give me 0. Okay? Now I'm going to substitute in pi over 4. So in here, in my calculator, I'm going to have pi over 4 cos pi over 4. I'm going to do 2 decimal places. What happens when I do this? Thank you, Tiago. Well done. 0.56. Okay, we're going to carry on doing that for all of x, and then the same with the y coordinate. Now, I like to write this because this is what I actually write in my calculator. And the only values I change are the values in the bracket. Okay? Now, there are some I can fill out. For example, I know that sine of 2 pi is 0. So I know this is 0 here. I also know that sine of pi is 0. So I know this is 0. The cos graph, I know that cos of 90, which is in fact pi over 2, is 0, so I know that's going to be 0. And the same of 270, which we know is 3 over 2 pi. So these I don't have to fill into my calculator because I already know them. The rest I do need to fill it out. And as if by magic, boom, all the coordinates are here. So what are we going to do now? We are going to sketch these, okay? Now remember, with a sketch, it's literally as accurate as we can. We know the first one is 0, 0. Is everyone happy that the first one's 0, 0? 0.56, 0.56 will be roughly here. Then we have 0, 1.57. So 0, 1.57. The minus 1.67, 1.67, it's a bit higher than that one, isn't it? Then minus 3.140, and that's about here. Minus 2.78, minus 2.78. 0 minus, wow, that's like all the way over here. Okay? 3.89 minus 3.89. 0. 6.2. Okay, you can clearly see we do not join these lines with straight lines, do we? It's going to actually look really beautiful, isn't it? Here we go. Now turn your page, paper, device upside down if you need to. I have to. There we go. That's amazing, isn't it? Nice and easy to sketch, just a little bit odd. So, are you ready to test your understanding? Okay, all you've got to do is sketch this graph. Okay, I'm going to help you out. We know that t is between minus 1 and 5, so this is our first row. And we know it's going to be minus 1, 0, 1, 2, 3, 4, 5. We then need an x coordinate and a y coordinate. We know that x equals 2 multiplied by t. So this is going to be 2 bracket in our calculator, or in our head. And we know that y is going to equal t squared, because it says in the question. Okay? So for each one, for minus 1, you're going to substitute it in here. So for the first one, our t is minus 1, so our x coordinate is 2 times minus 1, which is minus 2. For our y coordinate, we're going to substitute t is minus 1. Minus 1 squared is 1. Okay, so then I'm going to get 0, 2, 4, 6, 8, 10, because I could do that in my head. And then if I'm squaring everything, 0, 1, 4, 9, 16, 25. So now what I'm going to do is I'm going to sketch this. No, I know that none of my y coordinates are negative because y is t squared, which is positive numbers. And then if I was to sketch this, if I think about it, so I've got 0, 0, minus 2, 1, 2, 1, 4, 4, 9, 6, 16, 8, 10. No, I've done this wrong. Right. 0, 2. It's 2, 1. That is 2, 1, isn't it? Right, 4, 4. 6, 9. 8, 16, 10, 25. Okay, so remember this is going to be a curve of some sort. There we go. This is how it's going to look. Nice and simple. So this is just, I know we did some sketching curves earlier in the chapter, but this is just in case we don't know what it looks like in Cartesian form of sketch. Like earlier we saw a circle, that was fine, you know, quadratic, fine. But as we've seen on the previous example, it looked like a beautiful snail spiral, okay? We don't know how to sketch that yet, so when in doubt, put the numbers in, work it out. Okay, so this is it. In the book, exercise 3C, questions 4, 5 and 6. And that is the chapter done. Well done.